see. Did we do it? Did it work? Okay, we've got some people joined. I figure that's a conversation. Hi, good morning, good evening, good afternoon. Welcome to another Rick Rollicking show. Look, it's what is it? Thursday for me, and just about to be Thursday for me. Just about to be Friday for you. What time is it where you are?
I'm in Berlin, and it's 7 p.m. something over here.
Amazing. Thank you so much for skipping out and dinner and joining us. I appreciate that. I don't think we've ever talked in person before. So really big thanks. I don't know. So a few years ago, you started appearing in all of my feeds. I think the algorithm was just trying to tell me I'm stupid and I need to brush up on this space. And I don't do well with it's all empty. There's nothing in there, right? So I don't pick up stuff pretty quickly.
I think we're definitely on the same page in terms of having a big vacuum in the head. So I empathize with that. I think when you talk about me appearing in the feeds, this was the time just before, can we say the word, the thing in 2020? I don't know, on YouTube and whatever. Everybody knows, I guess. So there was a thing in 2020. So before that, I used to do DevRel, developer relations, developer advocacy, whatchamacallit. So I was very involved in the Go and Kubernetes communities. I used to do 20 talks a year in conferences and whatever. So when that thing happened in 2020, then it was like, well, now everybody's locked in a room, no more public speaking. And then I kind of slowly faded away from the algorithms. But that's probably where you picked it up.
Lucky me. So that was like 2019 BC, which is before COVID, right?
Pretty much, yeah. 2018, 2019, yeah, that time.
Well, that's cool. And we work together, actually. We're not together. We're on the same larger umbrella organization, which I think is that was a surprise to me. I didn't realize that when the algorithm started telling me about you. So that's cool. When did you join the bandwagon?
Yeah, I joined VMware, I think, in 2022, right in the beginning of 2022. So something like that. Yeah, it's been a while. Time flies.
Yeah. Lucky us. Lucky VMware. I just think about because that's the thing. I think I was hearing about you. What were you What were you DevReling before? Because I think I've heard about you since before you joined the team, the organization, the company.
Yeah, back then I was working at Tilt, and Tilt was
oh, cool.
Yeah, so we had exactly the interloop automation. So we were competing with tools like I forget all their names now, but Scaffold was one. Then Microsoft had one that was cool, but I can't remember anything now. But it's basically the inner loop of container development. So you write your code, and okay, now what do? I build a container, I ship the container, I orchestrate the container, and now my changes are live. And so what we were trying to do back then was remember Ruby? That was a good time. You write your code, save your file, magic, everything's live. So that's what we were trying to do back then. And Kubernetes was a new mysterious beast back then, and people didn't know how to set it up. And so we would come in with the solution to listen, just keep writing your codes the way you always did. It's going to run in Kubernetes. You're not going to notice. And that was the whole idea.
I mean, obviously things are different now, right? Now it's a old and mysterious technology that people don't know about, whereas before it was a new one, like you say.
I don't work with Kubernetes anymore, so it's not my fault.
Oh no, I don't know. I'm just teasing. It's great. I mean, I like Kubernetes. I don't understand it. That's different though. But I think we even had a blog, The Good, the Great, the Amazing Dr. David Sire. He's on the Spring team. He did a blog on inner loop development with Spring, and I think we even talked about Tilt. So,
Yeah, one of the last things that we did that I was involved in when I was working at Tilt is I think some component of the Tanzu application platform at the time, they used Tilt behind the scenes to do the live reload functionality. I'm not sure if that's still there or if people replaced it at this point, but I remember when I worked at Tilt, I remember working with some people from VMware to help them like plug all the plug all the sockets together and make things work.
Yeah, I don't I don't exactly know how or what we do. Actually, you are now arguably in a much better position to speak to me about what and how our platform story looks like than you, right? Because yeah, I mean, so what do you do? So where are you these days? I mean, I kind of gave away the plot there already, but
Yeah.
what are you doing these days?
So now I'm mostly focused on the security and compliance side of things, which can be very boring, especially the compliance part.
Right.
But it can
Well,
also be interesting. And yeah, I'm focused more nowadays on the platform side of things. So that would be where your applications run, not so much on the applications themselves. So yeah, for anybody watching, I was just telling Josh before we started, listen, I don't know anything about Spring. Don't make me talk about Spring, because
no.
that's that's a side I never got too much into. And that reminds me, I need to go talk to the Spring people, so I need to write down a to-do list for the parts where it intersects with the platform story.
Sure. Yeah, I'm sure we'd be very happy to have that conversation. All of us are very, very happy and grateful for people like yourself who are, at the end of the day, the reason we still have jobs. So, without you, there's no Spring, right? Well, I mean, that's not true. Spring is open source, but
No, yeah.
without you, it wouldn't be so easy and butter smooth to work on Spring,
I think to speak to that, I think the goal of any platform should be to enable developers to not think about the platform. So it's like when people talk about special effects in movies, like when it's done well, you don't notice it's there. And I feel like a software platform is kind of the same thing. When it's done well, you as a developer, you just do your thing. It just works. You don't notice it's there at all. So maybe that's not a thing people who want to sell the platform want me to say, but I guess I would say that the more it gets out of the way, the better it is.
Yeah, I mean that's a great point actually. I didn't think that's true. I mean, I'm nowadays I think we we talk to people a lot about the good, the great, the amazing, Cloud Foundry story, right? And I think that's and also before with the even we have a Kubernetes story that was sort of like a platform on top of that. And from a developer's perspective, obviously not from an operator's perspective, I don't know about the operator's perspective, but from a developer's perspective, I'm all about that. Yeah, do less is more here. The less I need to think about, the more I get out of the box. But that only works when we have people like you and countless others who working in different fields, who automate away the conventions and the sort of tedium that you get when you use one of those platforms, right? Like I can focus on apps as my currency. So I don't know. Because I sit so comfortably on top of that, at the very tippity top of the abstraction stack, right? I'm like the last mile of bytes and CPU, in any given computer. I'm the last piece that has to get working before I can call it production, but certainly not the most important. And a huge part of that is the stuff beneath that has to be secure. So is that kind of what you're working on?
Yeah, I think a big focus of my work is making sure that anything behind what the work that you do, that is basically that has a very mature security story. And I think especially when we talk about very large institutions, and in the case of my job, this would apply to, very large, like stuff that has a big impact that is strongly regulated. So we could think of financial institutions, healthcare institutions, all those kinds of things. There is a lot of regulations and guidelines, et cetera, that go that try to make sure that those platforms work in a way that is stable and secure and really something that you can trust,
Right.
so that when you put your applications on top of that, you don't need to worry about all that. That's built in. But unfortunately, the fact that you don't see it doesn't mean that it isn't a lot of work. So we do put a lot of work to maintain it.
Right. So when you deal with, I guess conceptually, where are we talking about? Are you sitting at the virtualization level, the operating system level, the Kubernetes, or the TAP, or I mean, I don't know roughly where's the. I guess, are you just in all those places? Is there concerns that you
A
worry
little
about?
bit. Yeah, so working in compliance, you kind of have to know what all the layers are, whether you're working on them or not, because compliance auditors will ask about everything and you need to give them an answer. If the
Right.
answer is, this is not my problem, you need to look somewhere else in the stack, you still need to know where to tell them to look. So you kind of
Right.
need to know the whole thing. But when we talk about the specifically application platform, application service, those things that we have at Tanzu, we basically, so you have your data center, with your power outlets, that whole thing. Those servers get virtualized, and this would be where VMware comes in, with vSphere and all of that. And then you kind of end up with like let's say a flat layer where everything looks standard and, all of your VMs are kind of uniform, etc. And then you're thinking, okay, I need to put an application platform on top of this. So like you mentioned, there's different systems that you can use for that. So there's Kubernetes. Right now we're focused on Cloud Foundry. And so basically, Cloud Foundry is going to sit on top of your VMs. It's going to create a pile of instances. In the case of Cloud Foundry, you're going to have a bunch of foundations. They're going to spread across the world in different regions. You're going to have redundancy. There's all the networking in between those. So from there all the way to, I'm a developer writing code, and I need a container to put my code in, or a droplet, depending on your paradigm.
Right.
And once I write my code and I put it there, that's when my job ends, basically. Where when you start writing code, that means, okay, my part is done. Now I just need to make space for you.
So that's a very good point. I mean, for a lot of people working in the YAML side of the world, right? Like if they're looking at, they might install vSphere and they see an ocean of vSphere, right? And then whatever people do within that, they could run Microsoft Word, they could run Cloud Foundry. It doesn't matter, like it's just a unlimited fountain of virtualization, right? And and so I don't know, what are the are there concerns there? I mean, so that's a good point. Virtualization, is that actually as opaque and black box and secure a container as possible, or is there still possibilities for leaks?
Honestly, I think it's very safe to treat it as if it's opaque at this point, because that is a very mature part of the stack. Similar to, for example, you can think of physical security, like, okay, there's a data center. You're going to have cameras, you're going to have generators, you're going to have all that kinds of stuff. And, we have, as a society, we have been securing, bank vaults and whatever forever. So like, we know how that works. We can assume we know how to do a good job there. So as far as virtualization, I don't generally worry about that layer. When we look, for example, at the VMware side, there's a lot of very good documentation and security standards and a bunch of stuff. So it is not something I worry about. Of course, people need to do their homework. But for me, it's not a big concern. And I'm sure you're going to get someone from vSphere here as your next guest, and they're going to say, oh, actually, it's a whole thing, and we are putting in so much work, etc. I'm sure that's the case. But for me, that's kind of outside the scope. So it's not a layer I worry so much about.
I assume it's pretty good too at this point, because they have like, don't the operating systems in turn, there's support in the operating systems these days, but also in the chips down at some level, right? Like, I mean, you can, these virtual machines, I don't know, I don't understand all of it, but they're using security down to chips, I thought, if available in certain architectures, or maybe I'm misunderstanding. So I always thought that was pretty great.
Yeah, that's also beyond my jurisdiction. But yeah, I think that is a solid story. And we have very good mechanisms to like keep everything above that layer isolated and not mess with it. So yeah, that's an area I don't worry about generally.
Okay. So then I guess are we moving up or sideways, or where are we going to the part where?
Then we move up.
Okay.
So if we look at the way like regulations work, for example, and I like to structure my thinking in terms of the regulations that exist, you're going to have. Is that depressing that I'm like, okay, what are the regulations that that's how I plan my spec?
This is where I hope people are getting out their pen and paper, because this is actually going to save you. Again, I think any technologist that gets into it and wants to just build just for the vibes and the tech, that's the most naive perspective. We're having this whole, V obviously, but for the people in the audience, there's this, if you're young and you're starting off in this industry working in technology, you're never it's never just gonna be the tech. You've got to be, it's got to be tempered by the real world, which is often moderated by mostly well-intentioned, helpful regulation. So, for example, private identifying information is a big thing, right? In software architecture design, and also right now in AI. My goodness, there's it's a wellspring of possibility, but also possible issues. And so we see new government, they're trying to sort of constrain it, but they don't understand it yet. So there's this little bit of a tension. But just the other day here in the United States, they introduced the No Fakes Act, right? It's not passed yet, but it's a proposal, and it's just interesting. You definitely pay attention to this.
Yeah. So, well, I'm not German, but you can look at my surname. You see that it looks German. So if you want to make fun of me that way, that works. I'm prefacing that because I'm going to talk about regulations again, because there is. So the U.S. government has released some guidance around securing AI applications. They've been updating it, I think, fairly regularly. I'm not sure if the latest update was from last year. I forget the exact name now, but it's like some kind of NIST AI framework, something like that. Specific, it's not down to the commands you need to talk. Did we freeze?
You said, yeah, you froze. You said something framework.
Lost for a second. Okay.
Yeah.
Yeah, so I think it was NIST. So NIST is one of the institutions that creates these regulations. So NIST did come out with a framework about securing, using AI things safely, etc. Their guidance is a bit high level. It's not down to the specific commands and thingamabobs you need to check. But they had some general guidance that's very helpful in at least understanding the architecture of what you're doing to keep your AI workloads safe. So even for these like very new things, we could say tip of the spear technologies,
right.
Regulators are always coming in and giving you some guidance.
Yeah.
So that's a thing. That's a thing that exists as well.
Right. So that's what I'm saying. If you can help us, if you can speak to some of that, that's valuable. We should charge for this video, but we can't because I won't. But that's valuable.
I mean, we could. Right. So what I was going to say before is I try to structure my knowledge of the whole stack in terms of regulations, because they're just a good way to frame things. And I was actually just working on a document about this, so I'm just going to pull it up here and give you a few highlights of areas that people should keep in mind. And for you out there listening, if you're a developer, don't despair. This is not all your responsibility. I'm just saying these are areas that across all the layers of the stack, you're going to have your platform people and all the different roles in your organization. And this is going to be a team effort. But I'm just going to give you a bit of what does the landscape look like. So for example, assuming the virtualization part is a solved problem, because that's not my thing, so I don't want to go into that. Let's say you have virtual machines. The virtual machines themselves, they need to be secured. So if we're talking about, for example, American regulations, because I guess that's most of your audience.
I don't know.
You would have. Sorry?
Worldwide, we have people from all over the world here on the old show.
But I think I'm going to focus on the American regulations just to keep a cohesive story. So we have these things called STIGs. STIG stands for Security Technical Implementation Guide. They are issued by, I don't know, some government entity, I forget which one. But they would have, for example, when you start looking at your stack, your VM, your virtual machines, they have an operating system. That operating system needs to be secure. So you would have, for example, a Ubuntu STIG, which is a checklist with a bazillion controls you need to follow, how you configure the system to be secured. And that's something you'd have to think about. When we keep moving along the stack, so okay, your virtual machine is safe, kind of. So where do you go next? Then you would have, for example, a container platform, SRG. So an SRG, I think it's, let me check, security, what does it stand for? Security Requirements Guide. So it's a bit different from the STIG, so different types of, paperwork you're going to find. But then you have, okay, a container platform guideline. So how do you secure the container platform? If you're using Kubernetes, you're going to have a Kubernetes STIG. So that's a whole different checklist of how you configure your Kubernetes. Yeah, you have something in mind?
No, I'm my little hamster wheel moving. Okay.
Yeah, and then as part of your platform, let's say you have a database in there, and if you're doing Kubernetes, you probably can have etcd or something. Maybe you have Postgres, and then there is a Postgres STIG, which is a whole bunch of a whole list of criteria, controls, things to think about how you configure your Postgres.
Is that so? These SRGs, who issues these? Is that just arbitrary organizational best practices, or what?
So so the ones I've been talking about right now, they are usually U.S. government entities.
Wait, so there's an SRG on Postgres?
Postgres has a STIG. So yes,
that's cool too, though, right? That's interesting.
Yeah, so that's I think it's called DISA, the organization DISA. I think they are the government branch who reviews those regulations. But yeah, there's a bunch of different institutions. But then they have this thing where they review Postgres and they decide, okay, if you want your Postgres instance to be safe, here's all the bazillion things you need to configure to make sure that it follows a baseline of security. Inside your application platforms, you're also going to have a bunch of different services and applications and dashboards and a bunch of helper tools, let's say. And then for those, you would have an application security STIG. So basically, what I'm trying to say is all across every little thing in your software platform, there's humongous lists with hundreds of criteria that you need to check and verify and prove to your auditors that you did that work. So yeah, it's a lot of work to keep a platform consistently following a baseline of security.
I didn't realize that. STIGs and SRGs. Okay. So these are more than just standards. These are more fluid. They can change year to year, week to week, that kind of thing.
They can change, but generally once they're established, if you do the work once, you can just keep up with the minor changes over time, and you don't it's not going to completely change everything generally.
Oh, okay. And so I see there's a STIG for deploying Linux, for example. Let me see. I'm looking for the one for Postgres, because that one I think is super, super interesting, right? I see different vendors, Crunchy Data, Enterprise DB. They all have blogs about.
I think those are just different websites. Yeah, those are just different websites with articles about it. But the STIG itself is kind of an official thing. So
I can't find that.
There's no.
Oh.
Yeah, I'll see if I can find it.
There's even a STIG specifically for Enterprise DB. Is that possible? It's on the NIST website. Oh my goodness, this is a whole new world. Bedtime reading.
Yeah, and vendors can create STIGs for their own applications. They just need to be submitted and reviewed. by this government entity. So I know that vSphere, VMware on the virtualization side, they have a few STIGs for some of their offerings.
Wait, so is this like a proactive thing? Basically, like, do companies submit STIGs on behalf of their own technologies before the NIST feels like they need to do it for them? Like,
no, basically the vendor submits it, and the government entity, they kind of review and check and approve it.
Oh my goodness. Okay, and so we just had a great question here, which is, does this apply to government projects or all corporate projects, or what's the?
Oh, okay. Now that's a lot of fun. So I've been talking about STIGs and SRGs, and they are part of NIST, which is a broader umbrella of these kinds of regulations. And that is one thing. So if you're a federal entity in the US government, whether you're, I don't know, like some very small little government office or some huge, I don't know, I don't want to name examples, but like whether it's a very small thing or a very big thing, if you're under the US federal umbrella, you will likely have to follow the NIST guidance that applies to whatever you're doing. If you're not a US federal customer, don't worry, there's a bunch of other headache you can find as well. So there's specific regulations for, electrical grid. So like, a nuclear power plant, they're going to have to follow some very precise guidelines made for them. Europe has their own entire world of different regulations. So for example, one that just came out is called DORA, which is, I think, Digital Operational Resiliency Act. It applies to entities with like a systemic impact, so stuff like big banks. And that's a whole, few hundred pages you're going to have to read to figure it out. A lot of commercial customers, they follow CIS benchmarks, which again, long checklists with a bazillion criteria. So you're going to have CIS benchmarks for, for Kubernetes, for your operating system, for your databases, for everything. So yeah, there's whatever jurisdiction you're in, don't worry. There is a ton of regulation you need to follow, so whether you like it or not.
What is the name of the job of the person whose job it is to like open up their email and look for the latest NIST or DORA or whatever standards?
It's compliance auditors generally.
Okay. Oh my head. That's like, oh wow. Okay. Okay.
Yeah, and I'm gonna say the magic words that probably a bunch of your audience here is familiar with is PCI. So anybody who ever got involved with something that deals with credit cards in any way, you had to make sure your application's following PCI guidelines.
Right.
So that applies to credit card processing generally.
Huge issue. I mean, is that your purview as well? Is that like apps level stuff, or? Oh, that is. Also, that's not below apps. That's on the same level as, at least in my perspective, right?
So PCI relates to anything in the environment where credit card information is processed or stored. So it includes the application and it includes anything that touches it. So the platform your application is in, the data, like your databases or whatever you're storing that information, that needs to be audited as well. I have this,
oops, do we lose her again?
Thing that takes the logs and puts the logs in that I get alerts or whatever. More bad internet.
Wow. Yeah, I'm back. Am I freezing, or can people in the audience tell me? Because
no, it's my internet that yeah.
Are you sure?
German internet.
Oh.
Maybe it's both. Yeah.
Yeah. I'm not assuming anything. I take nothing for granted. Okay, wait. So good question again. Great questions from this group here. How do government entities enforce these standards, or do they, or like who watches the watch people?
Okay, so I'm going to use the US again as an example because that might be the most accessible. So if you're in the certain US federal entities, you're going to have a person that, well, in order to bring anything you're developing into an operational environment, that is, if you want to put something in production in a federal agency, you're going to need a thing called ATO. That's authority to operate, and that's kind of the green light. So to obtain authority to operate, you're going to have to submit a whole pile of paperwork to your auditors. They're going to do a calculation that I think it's referred to as residual risk. So they're going to look at every checkbox that you are not 100% checked and that you have evidence to show. They are going to be doing the math to calculate what's the residual risk of the entire stack that this thing lives in. And then they're going to get back to you and say, hey, you messed up. Give me a whole nother bunch of paperwork that's missing. Or they say, yep, you're good. And then your software is allowed to go in production.
Wow. And that's for government agencies, though. That's not like a individual private business. Well, I guess even there, if you're doing business with the government, you probably are subject to this, right?
Yeah, the process is different for each one, but they follow the same logic, basically.
Oh, that's so cool. I didn't realize. Oh, okay. So that's a whole job. I wonder how, is there like a degree? It must be a degree or something like that, right? Like
there's a bunch of certifications. I'm not sure if a degree is required. Again, this varies by location and different types of different industries, but I know there's a lot of certifications that you take a course, you do some tests, and then you get certified as someone qualified to do this job.
Yeah. Wow. So is for better or in my thinking for ill is it the case that Europe has like is it the case that the United States has fewer regulations? I think that's probably true, and I also think that's a bit of a problem, right? I think we should be tamping down a little bit more. Is that, in your experience, true, or am I just off base?
In my experience, a lot of these guidelines start from the U.S. agencies, probably because internet and these very large systems, they kind of started in the US. So I think there's an ecosystem already there. I feel like a lot of the regulations elsewhere in the world, they adopt parts of the American guidelines and they put stuff on top. I think the perception that Europe is more restrictive is not because they have more of these regulations, but it's because the European regulations are more expensive. They cover more, like they demand more.
They're expansive, not expensive. Oh, okay, I see.
Correct. Yeah.
That's interesting. Yeah, that's what I'm saying. So okay, that is the case then. Yeah, and also I would suggest that by dint of being the second mover in your example, in your analogy, I'll bet the European regulations make a little bit more sense, right? They're not trying to pin down things that aren't really issues at all, for example, because they've already seen what the implementation looks like.
I like how they're done. I think they're generally very reasonable. I gotta say that I do prefer using the American regulations as a guideline because they're a lot older. So there's some structure to it. There's like a way of thinking that once you learn it, like maybe there's some description that doesn't make sense, but like what they're talking about. You've seen this 100 times. So I feel like there's a culture embedded in the system that makes it easier to reason about some things. And sometimes when you're reading some European legislation, like maybe the text doesn't make much sense, and you're wondering, okay, what does this mean exactly? Do I need to do this thing or that thing? You email your coworker from legal, and they email the European lawmaker person, and the European person is like, oh, that's a good question. We didn't think about this. And in the US, everybody asked all the questions 20 years ago already, so it's kind of easier to navigate that system.
I feel like at least in the app dev part of the world, I feel like when it comes to things like GDPR, it's the other way around, right? GDPR came first, and here in the United States.
But that's what I'm saying. But that's what I was trying to say. GDPR is more restrictive. It asks more of you, but it didn't come early, and it's not the biggest regulation. It's just the one that's asking for the most.
Right. Well, but also California. I mean, we don't have anything like that really nationwide in America, do we? I know California does.
I don't think so.
But California came after GDPR. So we're asking people from Europe for clarification because ours is more expensive than GDPR, or at least it's on par with it.
Yeah, well, one thing that's interesting though is that sometimes because so many of us work in companies where our products target a global market, we end up just following the strictest regulation instead of whatever applies. So it's like if I'm creating a software platform and most of my customers are in the US, but 5% are in Europe maybe, and I'm not saying these are not tons of numbers, I'm just making stuff up. Then like what I would do is, you know what, I'm just gonna tell my architects to take this privacy engineering training, and all the software we are going to design from the ground up, it's going to be compliant with those strictest regulations anyway. And that way we don't have to. So it becomes a global thing in the end. So I think the fact that you don't have some of this legislation in the US doesn't mean a lot of businesses aren't going to do it, because they want to sell to European customers too. So everybody's just going to follow it anyway.
That we have that here in the United States, even within the country, right? We have, in theory, we're one country, but we've got 50 different governments within, right? 50 different states, and so California has very strict pollution standards for their cars that are sold and driven on the roads here, and they're much more strict than those of the larger country, right? Well, imagine you're like Toyota or BMW or whatever, you're selling cars into the US market. You can't sell a car that can only be driven in 49 states, right? So by definition, California forces all car makers who sell into the US market to meet a minimum standard that they wouldn't have otherwise met. That's much higher than the federal government would demand,
Yeah, I think it's a similar logic, and I'm by no means claiming people don't go around these things, because but sometimes it works that way, and we're all better for it.
Right. Oh, that's so cool. Okay, so I didn't realize there's this whole thing like this. This is like a shopping list of standards. I mean, you could get bogged down just trying to keep this kind of stuff up to date, And there's legal consequences too, I imagine. Like,
it's a whole thing.
Do people go to jail if they don't do this? Like, what happens?
I don't know anybody who went to jail. Hopefully they don't.
Right. Well, I mean,
I'm not sure.
If you're part of the government, you just don't go live, right? That's until it's done. You're not production, right?
Yeah, I think usually the let's say punishment is that like you don't pass the audit, so you're not allowed to do business or take your application to production or whatever it is.
Right.
In some cases, institutions get fines. So like some bank, they have to follow regulation. If they don't, usually what happens is when an institution like that they're found to not be following something, usually they get a period where like, okay, you have X many months to get your stuff together.
Right.
So can I say that we've done this? But well, hypothetically, some institution might have reached out to somebody who works at an application platform to say, oh, hey, we're in trouble with some auditors. Can you help us figure this out? And then you can go in there, analyze the situation. Here's what you're missing, so we can help you solve your compliance story.
That is so cool.
In those cases, in those cases, you can get huge fines if you're that kind of institution and you're not passing your audits.
Oh, so that's amazing. So these organizations, well, it's in their best interest to hire somebody like yourself, or I mean, I don't know. Is this one of those things where
or to use a platform that does that job for them?
Right.
Which is what we're trying to provide.
Right. Okay. I didn't even think about that. I wasn't. I'm not smart. I didn't even make that connection. You're right. A platform would hide and automate away some of these inconveniences, and from the application perspective, when it comes to implementing the best security, there's nothing like Spring security. TM, ad inserted here. So, okay, that's super cool. I mean, what got you into this kind of thing? Like, why do this instead of developing the cure for cancer or something? I mean, you could have done. There's a fork in the road. Why go this way after DevRel instead of that way?
There's the cool answer and the boring answer. Which one do you want first?
The boring one. I'm always interested in the boring one. It might be the coolest one. You don't know.
Okay. Let me do it like this. So the cool answer is, in 1994, there was a movie called Hackers.
Yes, Hugh Jackman. No, I'm thinking of the other one.
No, that's Swordfish. Yeah, it's the one with Angelina Jolie and the guy who went on to be Sherlock Holmes. Yeah.
Oh,
so yeah, that was my favorite movie growing up. All the computer stuff I learned was like, I watched that movie and I was like, okay, I need to learn everything about this. And then I went into like, okay, I want to learn, back then, what was it called? Sysadmins. That's what, we didn't have like platform operators. It was sysadmins at the time. So I learned all of that. How do I configure my Linux and set up servers and everything? Got into security as well, learned to write C. So to me, that was the beginning. And then this stuff was always present in my mind, even when I was working in other areas. That was the stuff that I found cool when I would always gravitate to. The boring answer is, there was a time when I was working on a project and the project was, something happened to the project. And I was like, okay, what do I do now? And I asked my manager and he was busy with a bunch of stuff. And I was like, well, I'll get busy. And then I started doing security stuff. Turns out a lot of people don't like it. I don't know why. I don't understand how people cannot find it a lot of fun to go through thousands of requirements in a checklist, but some people don't find that fun. So I kind of picked it up, and nobody else was doing it, and I just kept doing it, and it's been like that for a few years.
Oh, that's so cool. So you started with C then? That you said C. That was that movie came out in the 90s. So that
Yeah, my first language was actually Visual Basic 6, probably. Yeah, but I had an extremely ancient computer back then, so it was super slow to open the, whatchamacallit, like whatever Visual Studio Code was 20-something years ago.
Visual Studio 6, right? Before .NET?
Probably, yeah. But I mean, the application itself, the editor for Visual Basic, it was too heavy. So my computer couldn't deal with it. So I was like, yeah, screw it. I'll just stay on my terminal here in Linux. And yeah, so I was one of those kids that like, I didn't use the graphic mode with X11, I guess it was called. Yeah, I would open that once a day to open the browser and do some things, but I would just stay in my terminal window writing C code, and yeah, that was my fun.
That's a great place to be. I rocked the terminal for a couple of years, but I started late. I was using Windows all throughout the 90s and up until 2002, and then I had a wonderful period where I just used Linux as my primary thing, and that lasted until 2011, right? So I was a pure Linux until 2011, and actually up until 2016, 17, I was rocking a Mac, but then the Mac started having such poor, they were like, you were stuck at 16 gigs of RAM in 2016. It was ridiculous, right? So I think I rocked a Linux, about one of those Dell Precision 5520s, and it came pre-installed with a Linux. I'm like, if it works on Linux pre-installed, then it's good for me, and that was great. Linux is a nice place to be, but
I think I started around the time that Debian Potato was coming out, so that's I don't know, year 2000 or something. Yeah, a long time ago. And but then depending on the job, I use a Mac. Now I'm using a Mac. Or if I'm doing more developy stuff, let's say, then I just go back to Linux.
Linux is amazing. Wait, so we've got Visual Studio. Visual Studio before it was Visual Studio.net. Do they still call it Visual Studio.net? Because there was like a brief period where it was like they added .net to everything. When it was fun to code and Park Place Smalltalk.
Jesus, Smalltalk.
Smalltalk's a nice language, but I don't.
That's a trip down memory lane.
Yeah. So okay, you were doing C and then C++, obviously the language of the computers. It's it's the Latin of computer programming languages.
Mhm.
And what you mentioned that you had eventually found your way to Go, right? You were working on
Yeah.
Go. What happened there? And what are your thoughts on Rust?
All right. So one thing at a time. So I was doing a bunch of stuff with C, etc., and then I took a long break from computer stuff. I was a musician, played in an orchestra. I took a
Cool.
quick break there. At some point, I decided, you know what, I miss having money. And then I went back into computer stuff. And this was just when Go was like on the way up.
Yeah.
It was growing. So I learned Go, I fell in love with it. It was basically all the stuff that I was familiar with from C without all the annoying parts. So it was like the perfect fit for me. I had tried to learn JavaScript back then, but JavaScript is just like, I'm not smart enough for JavaScript.
Me too.
Yeah, so at the time I recorded a course for Go, which in my home country, Brazil, I think to this day is probably the one people refer to the most. So it's the most comprehensive reference, I guess, for people trying to learn Go in Portuguese language. Yeah, I got involved with the Go community, got involved with the Kubernetes community. Yeah, eventually landed the Tilt, which was basically, you have those things all coming together. You end up with Tilt. Yeah, I've always had a big passion for developer experience.
Yeah.
I think it's such gratifying work when somebody's job is like weighing them down for some reason, and then you talk to them, you understand what the issue is, you put a fix in, and it's like you never have to worry about this again. Problem solved.
Yes.
Yeah, to me that's definitely one of the highlights, one of the most satisfying things to work on.
It's huge because it affects a lot of people, right? Like it doesn't matter what your final vertical is. If you can make the experience of building software easier, then it's a huge base. That's really a good win.
And developer communities are often very vocal, so you get a lot of very strong feedback, either positive or negative. But the conversation is always there. Did you just drink from like a yesterday's coffee mug or something?
No, just my morning cup of coffee.
Okay. But because you made a face there, I thought, did you just pick up your yesterday coffee?
Sorry. No, I mean, it's empty. And I'm just realizing that. I'm very sad. I'm also realizing that somehow I ended up getting the short instead of like the slightly larger.
Yeah.
I reckon this is like
mistake.
Yeah, exactly. I mean, this is the problem with ordering coffee before you've had a coffee, is that you're apt to make mistakes. So that begets more coffee.
Yeah, they should do like a 2-stage coffee ordering thing. Like you walk into the shop, you take a shot, and then you stand online to think of what you want to order.
Starbucks, if you're listening, arguably the single best thought that's been had on this show. Yeah, probably ever. Let me see. So I'm going to do the thing. I'm, hold on, wait for it, making coffee happen. And go to checkout. No, thank you. Don't want to buy the sugar. Priority delivery because I need my coffee. Place order. Done. Coffee has been made. Okay, show can continue. Okay, so Go is, I think, a really nice language, right? Did you, I need an AI agent to order coffee for me. Actually, that's a good point. Years ago, when the Spring Boot stuff started, the co-founder of Spring Boot, a guy named Phil Webb, he's based here in San Francisco, where I'm based. And he and I were doing these demos. We were like going around doing conference talks and user group talks, talking about this then brand new thing called Spring Boot. Ooh, Spring Boot. And we had this demo where we had a Raspberry Pi that was polling. It was a little Spring Boot app running on a Raspberry Pi that was polling. This is 2013, mind you, so it's a long time ago. And we had this Spring Boot app polling on the Raspberry Pi a Spring Boot actuator endpoint. And the actuator endpoints are like your Kubernetes liveness and wokeness. What?
Okay.
It's like liveness.
No, I got it.
Yeah. But it also provides metrics and distributed tracing, and it's all this other stuff, right? It's not just Boolean ready or not, And so we had this health endpoint kind of, and you're pulling this health endpoint from this Raspberry Pi, and the Raspberry Pi was connected to a coffee machine in our demo, right? So as soon as the app that we deployed, as soon as we artificially introduced an error, such that the state of the software was failing, well, then the Raspberry Pi would see that the health status has flipped from green to red, basically from healthy to unhealthy, and it would then go, okay, well, this person's going to need coffee. They're going to be up all night, so it would start making coffee. The Raspberry Pi would we use Pi4j to trigger the coffee machine to start making a cup of coffee, and anyway, I imagine that with AI, like connecting my Raspberry Pi to with an AI application, talking to my coffee machine to figure out when I'm going to need coffee and just proactively make it.
You could connect like your Apple Watch or Aura Ring or something like that, and have a thing that like when your biometrics show that you're sleepy, it makes coffee automatically.
Yes. Well, or okay. You know what a nappuccino is?
No.
Okay. So I spent a lot of time traveling, as I'm sure you did, but I was doing 1 million kilometers a year for, almost a decade. And
as one does, yeah.
Yeah, and so I started getting into trouble with my sleep schedule. My body was like, "Oh, don't," and I'm like, "I gotta." And there was a fight. So anyway, I lost, both of us lost, both my body and I. So I discovered this thing called the nappuccino, and basically the scientists, the nerds for this explanation, discovered that you are unable to. Coffee won't wake you up. It's a misconception, right? All it can do is prevent you from getting tired in the first place. But if you're already tired, it's too late. The only way to fix that is to go to bed. You don't have to go to sleep for a long time, though. It turns out like 20 minutes is enough. And so it also, coincidentally, takes about 20 minutes for a cup of coffee that you drink to start circulating in the bloodstream. So you take a cup of coffee, drink a whole cup of coffee, then take a quick, set your alarm clock on your watch or your phone or whatever, and your Vision Pro if you can sleep in that, which is insane. And then sleep for 20 minutes, right? So you drink a cup of coffee, sleep for 20 minutes, wake up, and the 20 minutes is important because you don't want to enter REM sleep. It's too hard to wake up, right? You don't even need to clear the sense of tired, And so this cup of coffee plus 20-minute nap, that's called a nappuccino, and it's much more effective than either sleep or coffee combined. It both clears existing sleep and prevents the onset of more sleep, which is a great result.
Okay, I'm not sure if that's healthy. I can see it being helpful.
Not. It's helpful. Yeah, it allowed me to straddle time zones where I wouldn't have otherwise been able to. But not even that. At some point, your body's going to go, hey, I need real sleep, please. But if you're just trying, like I'd land in a country, I had a day worth of meetings, and I had to leave the same country that same night to get to the next place. How am I going to? I just need to get from one plane to the other in one piece. That kind of thing.
I had a question for you. You said another time that Go made Java better, and I wanted to ask you what happened there.
Okay,
as a background, I was a Java developer for like 3 months of my life officially. It was not Spring. I don't know what it was, but it was terrible. And this was like. So there was a time when Java was new and everybody was hopping in, and then there was a time where Java was like, Java. And then Java became like, oh, now there's Spring and I don't know, Kotlin, whatever it's called. And like, it's cool. Like people are happy with it. But there was the time like this lump. So that's when I was a Java developer. So I'm very curious to hear from you. How did Go make it better?
Okay, indirectly and directly. So so I'll talk about my theory first, okay? In 2000, when did Kubernetes get created at Google? Like, what are they, 2009, 2010, 2011? They're working on it, right? I don't know.
Maybe. Let's see.
So I kind of wonder, at some point, like,
do you want me to use ChatGPT to answer?
Wait, what? No, go away. My Siri just started talking, and nobody asked it. Nobody asked.
2014, apparently.
Well, that's when it came out. But when did those people start working on it, right? Joe Beta and the rest. When did they actually start?
Okay. Yeah, we need to get Joe on the call.
Right. So, okay, so let's assume like 2010, 2011, 2012, I don't know, whatever, some years before that, right? And my question is, ignoring that Go came from Google and Kubernetes came from Google, because I don't know that actually had as much of an impact on the decision-making as some people might imagine. I don't think it did. Ignoring that is the case, what would have needed to happen? What would have needed to be in place for that amazing team who are skilled, competent, and gifted engineers and could have done whatever they needed to do in any language? What would have needed to be there for them to have chosen Java in lieu of Go? And my theory is that at the time, looking at Java circa 2010 to 2015, whatever, or even 2020,
Can I guess?
Yeah.
As someone who hasn't been a developer in 100 years, I would say big binaries and memory footprint, and the infinite interfaces, etc., that Go has.
Big
Am I
binaries.
close?
Are you talking about like statically linked native images, native binaries? Like
I guess what I mean is you need the whole JVM thing, and that
oh,
puts
right,
some
yes.
strain. You
That's one.
don't have the tiny binaries that Go does, or didn't at the time. I don't know.
You're 100% right. And that's one, okay? And the footprint, memory footprint, that's another. The interface with native code, interface with POSIX and all these other C libraries that you couldn't really easily get to from Java, that's another. And then I would bet something else that's pretty interesting, and you can kind of see it reflected in Kubernetes is Go routines, right? Go routines are scale sauce. You sprinkle the scale sauce, and it just works. And that's why Google wanted to Go, was because it made it easy to build network services. So I think those things are really important. But where are we right now in the Java ecosystem? Well, we have Project Panama. Project Panama gives you, it's released, it's already out there. You can use it for a couple years now in GA final form code. And it gives you like a reflection API for native libraries, right? So I can look up symbols, I can invoke them, and there's even a tool called JLink, I think, that you can run and point it to a header file, and it'll generate Java code that behind the scenes use this low-level reflection API for native code to look up, invoke, and then dispatch to other native libraries. And there's even, if you want to, in low-level Java code, there's even things that you can use to allocate memory, free memory, these set pointers, set fields on a struct, right? And all that stuff.
I'm hearing Kenny Loggins in the back of my head, like highway to the dangerous.
Yeah, exactly. Yeah, well, I mean, it's a auto closable, it's like a with resources kind of thing. It's you allocate some memory, and within that, it's native memory. It's off heap, right? It's native code, just like you had run C malloc, and then there you can set the offsets and things like that in the memory to map it to the layout of a struct in C code or whatever you want, and then you can pass that memory region to in Java it's called a memory arena, I think, but you can pass that to functions and have the function operate it, and then it's a pointer so you can get the memory back out and look at it, what has been done, and all this kind of stuff, So easy interoperability is there now, right? It's effectively as easy as it has been in Go, or Python, or Ruby, or TCL, or every other language, .NET, every other language except for Java, right? Java has never been good with native interop, never. It's just been terrible. And I think that's been by design, like credit where credit's due. You can do basically almost anything in Java, in pure Java. You don't have to worry about installing a native library in C or whatever. Whereas with Python and every other language, you're like, will this run on my operating system? Who knows? Let's try it and see what happens. Who knows, right? But in Java, most things in Java are written in pure Java, and so there's no question. The whole ecosystem is all pure Java, right? So that's good and bad, because for 99% of the cases, if you're doing enterprisey Java server-side kind of things, Java's great. But once you want to do like, embedded stuff, or if you want to talk to, very small different kinds of architectures, sometimes you just need to talk to the hardware, right? Sometimes you just need to have this native access. So now Java has that. I don't know that was inspired specifically from Go, but one assumes that Go and the ease of interop from .NET and Python and Ruby and Perl and TCL and PHP and every other language in existence ever since any time ever, you would assume that informed Java. That's one. Two, native images. So we have GraalVM now, right? GraalVM is a way to create native binaries from your Java code. So it's AOT basically. So you still keep the garbage collection just like Go, but the resulting Java binary can be, like 1/10 of the RAM footprint, and it's a statically linked self-contained binary. So I can say, I can ship a CLI in Java, and I can compile it into my CLI.exe for Windows, or my CLI for Linux and Mac, right? And I can also export Java code as dilibs and .so files and .dll files as well, right? And they can be linked to from Rust or whatever. In fact, that GraalVM technology, just a few weeks ago, I put a video up on this very channel. There's a preliminary, early days, not yet production worthy, not even close to production worthy, but there's a preliminary thing where you can now export. You can target WebAssembly as a backend with Java, right? Yeah, exactly. I mean, things are getting really interesting,
Crazy.
right? So that's interesting. And then the final thing that we talked about. So that, by the way, those native images are usually like 1/10 of the RAM footprint as well. So
yeah, the thing that always scared me about Java is that. So I'm a bit of a nerd. I'm not sure if I come across this. So when I was writing C, the way I would do it is like, okay, there's a standard library. I can get the source code for the standard library, and I can read the whole thing. So I know what's going to happen behind the scenes when I do whatever I do with my code. And with Java, I never understood, like, okay, there's a Java VM. What is it doing? How does it work? I'm not sure if this information is accessible or easy to understand, but to me, it was always like there's some mysterious layer that I don't understand. And to me, that's the thing. When I went from C to Go, it was like the Go standard library. It was like so easy to find, and like you can just go read the whole thing.
Right.
So to me, that was like, oh, this is easy. Okay, I know how to think in these terms.
That's fair. Yeah, there's the runtime in Java is definitely more fully fledged, right? Like most languages have a kind of runtime, but it's a question of what can your runtime do for you. I mean, even things like garbage collection in Go, that's a runtime, right? There's something above your code or around your code or whatever. Okay, and then finally, the last thing, and this is where I think that we can draw a direct comparison here, is scalability, is threads, Go routines, right? So I'm sitting there on a thread. A web request comes into my server, and I've got a thread assigned to the socket, and so whenever a new socket hits my server, a thread gets dispatched, and then inside that thread, the program code reads from the incoming socket, does some I/O, maybe calls a database, calls another AI model, does whatever, produces some bytes, and then sends it back via the same socket to the client that just came in, and then the thread gets put back in the thread pool. That model works just fine as long as A, you've got enough threads, or B, you're not wasting time on those threads, right? That's that wasting time when you're sitting there doing things
like you're talking about processor threads, not virtual threads.
Yeah. Well, yeah. So in Java before that, we only had processor threads, right? We had threads.
When I started learning Go, that was the big argument that Java used virtual thread, used real threads, and then you had that limitation.
Right, and all, a lot of languages like have this fundamental problem of people need to do things that take time. Those things that take time often are done in the hot path to the CPU, which is a waste of both the thread and the CPU because nobody else can use that thread, and therefore nobody else can access the CPU. And for things like wait for bytes, that's a waste, right? Don't wait for bytes on threads, right? And so is there a way to write your code in such a way as to avoid that that hang up? And there's programmatic abstractions that you could use, like reactive programming, which I think are pretty neat. And in JavaScript, they had not publishers. What do they call them there? They called them, you do like window.fetch, then whatever, I forget what it's called, where you can flat map over the promises. They call them promises in JavaScript.
Right.
And all that kind of works, but it's very asynchronous code, right? And so eventually in JavaScript, and actually in C# and then JavaScript, maybe it's the other way around. Maybe it's JavaScript first and then C#, I forget. One of those two was the first. They had this syntax called async await, right? And with async await, you write your code, you say, okay, this function is going to do a thing that's going to wait, So feel free to just put it in RAM, take it off the thread, and then when the bytes are here or the thread.sleep is finished or whatever, move it back onto another thread so it can continue, right? But you have to write async and await all over the place in your code to do this. So your code ends up becoming this very complicated mess. And if you use async await, if you use a awaitable function in some place in JavaScript or C#, then the function around it has to be awaitable as well, right? So you can't just isolate it.
I wonder how this works if you have a debugger and you're just trying to step through your code and you have all these async awaits. You might find some discontinuities there.
Yep.
Because
yeah. So you're right, 100%. That stack frames get moved around. There's all sorts of weird stuff there. Yeah, it's very, very convenient, but it's also very, very painful because you have to know about this discrepancy in JavaScript, which was originally written without async await, and then they added it. So here comes Java, right? So most languages adopted the async await paradigm, right? Except for Go. Go was built brand new. They didn't have existing legacy, blocking IO to worry about. So they built everything as non-blocking IO by default. So even the simple, if you read from a network socket in Go, it looks like blocking IO in Java, except that behind the scenes, because you have these virtual threads, these Go routines, it's actually not. It's actually the Go language itself is doing the scheduling, not the operating system, right? The program, the runtime, right?
And somebody mentioned Smalltalk. If I recall correctly, the technical implementation in Go for what you're describing was originally implemented in Smalltalk.
Really?
I forget what it's called now. It has a catchy name. It's something about the non-blocking threads or something. I would have to dig down way back in the memory lane to remember the exact name. But I think this concept started with Smalltalk. Go picked it up, and I guess from Go it went everywhere.
Well, you might have just undercut my one big kudos to Go, but let's just assume it's Go for now. Okay. Either way, certainly the most widely visible thing that did this in modern recent memory was Go, right? Anyway, so Go did it right. They have the scheduling mechanism in the language itself and the runtime there, as opposed to delegating to operating system threads. Fun fact: Java actually did the same thing-ish when it first came out. So 1.0, Java 1.0, we had green threads, right? But the implementation was deemed to be too complex. So they actually undid that and moved to operating system threads. And so basically one Java lang thread equals one operating system thread. Anyway, so for most of Java's existence, it was the bad kind of threads, right? And it wasn't really a big deal for the first 5-10 years because you're building Java applets. Who cares? It's going to run in the browser. You're not going to have 1,000 threads anyway, right? But obviously this is a big issue. And Go, I think, did a really good job. But they had the benefit of starting off with virtual threads. They never had legacy. They don't have to make two worlds exist. So the JavaScript and these other languages, they added this async await keywords, right? Which is nice because it means that you can now take advantage of this, but and you can keep your existing legacy code behaving in the bad way that it behaved before if you really intended to rely upon that behavior. Because like you said, there's these little idiosyncrasies that come with doing this async await kind of stuff, right? Stack frames and things like that moving around. So if you really are hell-bent on keeping the existing semantics, fine, that still works, but now async await. So here comes Java. And Java was like, well, okay, we want to make it so that, because we have existing blocking IO, same problem, we can't afford to be 100% sure that everything will work exactly the same, and we don't want to break things. How can we introduce this in a way that is minimally invasive, but gives people the benefits of non-blocking Go routine-like threads? And the way they did it in Java was by changing the type of thread itself, right? So and usually in Java, you just got one place where the type of thread is created. It's called an executor service. So for most applications, you just change out the object of type executor. It's a different subclass of executor. And now you've got these new kinds of threads, completely transparent to the rest of the code base. No changes at all.
Okay, so you kept the same interface and just kind of changed the implementation.
And now you get non-blocking Go routine-like IOs, the same kind of scalability, completely free. And so it reads like blocking, imperative code, just like in Go. It looks exactly like that, but behind the scenes, whenever you do input stream.read or output stream.write or thread.sleep or whatever, the runtime says, hey, I'm going to move you off of this thread, put the thread back in the thread pool, and when you're done, when there's a byte available, I'll put you back on the thread and let the runtime continue from there, right? So you can actually print out before the blocking operation. You can do thread, system out print line thread.current thread, and then toString it. You'll see the thread you're on before that, and then do the system out thread.current thread after the blocking operation, and you'll see that the thread has changed automatically.
Yeah.
It's really cool, right? And that's Go. I mean, Go did that.
Yeah.
They didn't do two worlds, but they did have this like you don't even know mentality. It's nice and elegant there. Big fan.
Sometimes it's funny how computers are always the same when you think about it, because like you're describing that, and I'm thinking about the Kubernetes control loop with the operators and that kind of thing. And it's kind of very similar. Like the control loop just goes through every operator. Hey, do you have any news? Nope. Keep moving. Oh, here's a thing. Do this operation. So we keep re-implementing the same things over and over again.
Yep.
Just
so actually,
slightly different ways. Yeah.
Totally different. And I mean, Go is really good. I'm not going to sit here and say it's the same as Java. It's different, but also equally beautiful, But you mentioned the Kubernetes operator. So you wouldn't believe me. People look at me and go, this guy's too stupid. There's no way. But I'm actually a contributor to Kubernetes because I worked on the Kubernetes Java client, right? And one of the things I did was I submitted, and that's maintained by, who's the guy at Microsoft? Of the three founders, which is the one that went to Microsoft? Not Joe Beta.
Bill Gates.
What?
I said Bill Gates. He's at Microsoft.
Oh no. Okay. He's come on. I can see his amazing. I can see his face in my mind. Anyway, it'll come to me. But my point is, the Java client there has GraalVM native image support, so you can build a Kubernetes operator in Spring Boot.
That's cool. Okay.
Controller, and it takes 30 megs of RAM, whatever, instead of 300 or 3,000 or whatever. And it can be a native Linux binary that you deploy to your cluster. Anyway, Go's awesome.
What's okay? I'm not sure if it's the episode's gone on for too long. I do have a question though.
Yeah.
What do you currently have in Spring for let's say developer quality of life things? And I'm specifically thinking about like fast iteration. So, live reloads, that kind of stuff. What's there nowadays?
Dev tools. So the other thing that's amazing, before we will move on, but kind of in the sort of Venn diagram overlap of what we were just talking about, GraalVM native image, if there was one drawback, and this is a huge one, is that it takes forever to compile, right? Whereas with Go, it's just instantaneous. Right? You can put 1 million files there and Go will just chew through it. For smaller code bases, it's really fast. For larger ones, it gets really slow, but still it does a very good job, right? You don't feel slow. So GraalVM, you do that, you end up taking you'll do that once a day as opposed to every iteration, or whatever. You'll do that in CI. You don't do GraalVM all the time. If it takes like a minute.
You couldn't live reload that kind of application.
You would. So the way that people work in GraalVM is they write their code and they run it on the JRE cycle through that. And then they make sure that GraalVM compilation preserves all the behaviors that they saw as when they're developing it. And usually if there's some traps, right? Some things that may not work without a little bit of extra tweaking, and they're well known and it's easy to kind of navigate that swamp,
Got it.
So now, DevX, you talked about that. So assume that most people are spending 99.99999% of their time on the JVM. Even the JVM can start up. If you have a Spring Boot app, it's not unreasonable to start up a Spring Boot app in half a second or a second, right? It can be very slow, right, like that. So, and that's because of the JVM, right? The JVM itself, just because it loads all the classes and does all this class loading, that can be very slow. So we have this thing called DevTools. And the way that DevTools works is it's literally just a thing that sits there as you're compiling your code in your IDE, right? Or whenever you do save or whenever IntelliJ updates or whatever, it'll automatically detect that you've compiled new class files that are sitting there in the directory. If it sees that, the dev tools will throw away the existing class loader, right? So basically let me try again. You start the program in your IDE. It creates a new virtual class loader. The class loader has all the current compiled loaded classes in memory, but it's running inside the JVM, and the JVM can have multiple class loaders, right? It can have a class loader for different layers, different isolation tenants, whatever. And the virtual class loader is in turn monitoring your output target directory full of class files. As new class files appear, it throws away the current class loader, loads all those new class files into the new class loader, and then starts up a new Spring application context with that new class loader, right? So your existing JVM is still running. So what would have been a 1 second restart time on the JVM becomes, 2/10 of a second or something like that. So if you're using IntelliJ, you just hit Alt Tab. By the time you get to the browser and hit reload, it's there.
Yeah, when I was at Tilt, we used to do something that's a similar way of thinking, but back then we were thinking only in terms of Kubernetes and containers.
Right.
So back then, what people would do is, you change your code, and then we create a new container, push it, deploy it, etc., and that would take forever. So like one of the things we did back then that it was like not difficult, but it was probably the one that had the biggest impact was like you just never redeploy your container, like just keep the container there and we change what's in it. So I guess that's similar to what you're saying. Like we instead of restarting the container, like don't kill the container, don't restart it, don't redeploy. It's just like, you changed this little bit of code, we push that to the container, spin it up again, but you keep all the you could say logical infrastructure in place and just change little bits of it.
Totally. I mean, and I've used that before. It's great. That's a great production. Like, because again, I hope people are building their Spring apps in such a way that it's all environment variables, and so you can isolate and you can have your local development environment variables pointing to one resource, and then your integration environment variables pointing to another, but it's the same Java code, And if that's the case, I think most people should start with just public static void main running on their local workstation. Or whatever, their computer. But, you really do want to have a good, does this play nicely with everything else in integration, right? And so Tilt, I think, is super, 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 super good. That kind of stuff is really good. We talked about, like I said, there's been at least 1 or 2 blogs and talks on how to use Tilt with Spring. Good stuff. So I don't know. This is this kind of stuff is all the stuff we just talked about is kind of eye-watering. It's really helpful for me to talk to people like you to learn about all the stuff upon which anything I'm doing depends. I can sit easy and comfortably knowing that people like you have read those STIGs and security requirement guides, SRGs, right? I really am grateful. I know most of us are grateful. I am also particularly stupid. I don't even sometimes realize just all the stuff that has gone into making it so that I can work so happily at this layer. I appreciate you taking the time to kind of walk us all through it. Are you feel free to say no, but are you on the internet? And if so, do you want to be found? And if so, where can people find you?
Right. Yeah, I'm not on the internet anymore, actually. I used to have a whole thing on Twitter and YouTube, but that was many years ago. Ever since, it's been a few years that I kind of just don't use the internet anymore, basically. I'm the kind of person that people come in, they come to visit my home and they're like, "Oh, you don't have a separate network for your smart devices?" And I'm like, "Buddy, the only smart thing in this apartment is you. There's nothing smart here." Yeah, so I've been kind of taken that way. But we can always come back and speak again. So that would be great.
Oh, and that makes it's even more of a rarity. Thank you.
Yeah, and you were explaining. I was asking you a few details about Spring because I'm selfishly thinking, should I go talk to the Spring PMs and stuff? And there's some security stuff we can do there.
Sure.
So yeah, I don't know. Let's see what happens. That'll be super fun. It's
Yeah, it's a good community.
I think it's a very powerful environment, the one you're in with Spring, straight in the hands of developers, where the real magic happens. Because at the end of the day, the whole point of the platform is to enable developers to create, what their businesses need, to create value in that way. And maybe I guess the more we can bridge the gap between, here's the platform, it's a whole thing, and the developers are on the other side, it's another thing. I feel like there's a lot of opportunity to fill that gap. So a bunch of the things I was asking, it was like, okay, is this a thing? Maybe we continue maybe there's some roadmap we can do about how to bridge those worlds. So that would be interesting.
That's always, I mean, that kind of stuff is really good, right? I mean, yeah, I appreciate that. If I know it's super late for you, I'm happy to.
I have more meetings today.
Right. Yeah. Okay. Well, I'm happy to chat afterwards. I'd love to show you the latest and greatest in the Spring ecosystem. But in the meantime, thank you so much. Thank you. For
you're welcome. Anytime.
It's been super elucidating. I'm going to go back and rewatch it and take notes because I learned a lot about this kind of stuff. Thank you for your time.
And everybody watching, go email Josh if anything was interesting, and we can pick up the conversation next time.
I mean, we got some great comments here. Thanks everybody for hanging out. Hope you got something out of this. And for those of you watching on the old YouTube and stuff, like and subscribe and that kind of thing. Okay. Good night. Good afternoon. Goodbye. Good day.